Good morning, everyone. A very good morning to all of you. The thing is that today, one second, please. Today, we are going to complete the overview of medicinal chemistry, and we will see how to study that medicinal chemistry. One second, please. So, I don't know whether I am audible or not, but today we are going to complete medicinal chemistry, mainly the drugs which are acting on CNS and the drug which are acting on ANS. These two are very important. The drug acting on CNS and the drug acting on ANS, these two topics are very important. You have to understand that two topic and you have to learn properly. And also the drugs who are acting as, that is called chemical who are acting as chemotherapeutic drugs. So chemotherapy, in that chemotherapy mainly you will understand antibiotic, types of antibiotic, their structural activity relationship, mechanism of action, and after all these things we will see whether we can complete that or not. So drugs acting on CNS and drug acting on ANS, these two are very important. You have to remember that from these two topics you will get so many questions. Okay, you will get so many questions. So first of all we will start from the drugs who are acting on CNS. Okay, so the drugs acting on CNS are of so many types. Why I am telling so many types? So many types in the sense, see, if a drug which is mainly acting on your brain or CNS, that CNS is consisting of brain and spinal cord, right? So we will see what are the drugs they are mainly acting on CNS. Okay, so in that CNS, now we will see the drugs acting on CNS. So what are the drugs that are acting on CNS? The drugs that are mainly acting on CNS are: number 1, sedative and hypnotics. Sedative and hypnotics. Then you will see anti-epileptic drug, and then you will see antipsychotic drug, These all drugs mainly acts on CNS. So what are they? Sedative, hypnotics, anti-epileptic drugs, one second. I think it would be better if I change the orientation like that. Which one is better? Okay, I'll write like this, no problem. So sedatives, hypnotics, anti-epileptic drugs, antipsychotic drugs, then antidepressant, drug, then you will see general anesthetic, and then you will see local anesthetic, local anesthetic, and then you will see opioid analgesic. What it is called? Opioid analgesic, and then also the most important, they are anti-Parkinson and anti-Alzheimer. So you have to write anti-Parkinson, and anti-Alzheimer drug. I think I have to fill that marker. One second please, give me some time, I will fill that marker and I will start writing. So these all are the drugs who are acting on CNS. So what are they? Please repeat after me. Sedative, hypnotics, anti-epileptic drugs, antipsychotic drugs, and antidepressant, then general anesthetic, then local anesthetic, then opioid analgesic, and anti-Parkinson. Okay. So one second please. Let me fill the marker and we will start about the structure of the drugs. So we will start from the very basic, and if you want me to rotate the orientation, then I will also rotate the orientation, don't worry about it. Okay. So let's start from the very basic. So the drugs acting on CNS are sedative, hypnotics, anti-epileptic, antipsychotic, antidepressant, general anesthetic, local anesthetic, opioid analgesic, anti-Parkinson, and anti-Alzheimer. Okay. Now we will start from the very basic, that is sedative and hypnotics. Okay. So we will start from sedative and hypnotics. Let's start. Sedatives. And hypnotics. So basically you have to remember what is sedative and hypnotic. Sedative are those drugs who reduces the anxiety and stress without inducing sleep, whereas hypnotics are those drugs which reduces anxiety and stress but with inducing sleep. So the one who is inducing sleep is hypnotics, but the one who is not inducing sleep is sedative only. Okay. So you have to understand that what is sedative and what is hypnotic. Okay. Now we will see one very important point, that the drug which reduces anxiety and stress is without inducing sedative, stress inducing sleep with inducing sleep, then it is called hypnotics. Now we will see the drugs and their classification. Okay. So classification of the sedative and hypnotics, in that first you will see barbituric acid and their. Okay. So we will see now sedative and hypnotics. So sedative and hypnotics. Basically we will see three type of drugs. How many types? Three. Number one is called barbituric acid derivative. So barbituric acid and its derivative. Number two we will see benzodiazepine and their derivative. That is also called BDZ. Benzodiazepine is also called BDZ. Benzodiazepine and its derivative. Okay. Number three we will see, and that is pyrazolyl pyrimidine. Number three is pyrazolyl pyrimidine, and that is most important. Pyrazolyl pyrimidine is most important. So you have to remember how many types of sedative and hypnotics are there. They are basically three types. Number one is barbituric acid derivative, number two benzodiazepine and its derivative, and number three is pyrazolyl pyrimidine. Number three is pyrazolyl pyrimidine. Okay, next I think it will be better if I write from top to bottom like this. Number one, barbituric acid. Barbituric acid and derivative. Okay. Number two, BDZ. BDZ means benzodiazepine. Benzodiazepine and derivative. Number three is pyrazolyl pyrimidine. Pyrazolyl pyrimidine. Yes or no? Next, number four is imidazolyl pyrimidine. Number four, imidazolyl pyrimidine. Imidazolyl pyrimidine. And next, number five is cyclopyrrolone. Number six is piperidinone. Are you getting? Number six is piperidinone. Then number seven is piperazine derivative. Piperazine derivative. Next, number eight is parasympatholitic such as scopolamine. Okay. Next, number nine is carbamate ester. Number nine is carbamate ester. Example, meprobamate and something. Yes or no? Carbamate ester. You have to remember that carbamate ester is very, very important. Next, number 10 is serotonin. Serotonin precursor. Number 10 is serotonin precursor. Okay. Next, number 11 is chloral. Chloral derivative is number 12 is miscellaneous. Number 12 is miscellaneous. So how many types of sedative and hypnotics are there? Number one is barbituric acid derivative. Then number two is benzodiazepine. Then number three is pyrazolyl pyrimidine. Number four is imidazolyl pyrimidine. Number five is cyclopyrrolone. Number six is piperidine. Number seven is piperazine derivative. Number eight is parasympathetic hormone such as scopolamine. That is also in that parasympathetic. This one, yes. Where is number 8? Parasympathetic. You have to remember in that piperidine and pyrrolidine and epoxide all are present, that is oxidine. Okay. Next, number 9 is carbamide ester, number 10 is serotonin precursor, number 11 is chloral derivative, and number 12 is miscellaneous. Okay, now we will see each drug. For example, the first one is barbituric acid derivative, right? So we will see all the barbituric acid derivative drugs and their structure and also their mechanism of action, not mechanism, structural activity relationship, SAR. We will see now. SAR we will see now. Okay, so the number 1 is barbituric acid derivative. Before going to the drugs, I have to mention one very important thing is that barbituric acid derivative, they are again of 4 class. They are again of 4 classes. What are they? Number 1 is long acting. Number 1 is long acting. Next, number 2 is intermediate acting. Intermediate acting. Number 1 is long acting. Number 2 is intermediate acting. Next, number 3 is short acting. Short acting. And next, number 4 is ultra short acting. Ultra short acting. So what are they? Long acting, intermediate acting, short acting, and ultra short acting. Okay. So what are long acting? Long acting drugs are those drugs who will show its pharmacological action or therapeutic action for longer duration after taking a short amount of drug or very short quantity. Okay. Now we will see each of them. Okay. Before going to that, I think it will be better to make you understand about the SAR. Okay. And also one important point I forgot to mention is that long acting example, what are the example of long acting drug? The long acting drug example are phenobarbital and methylbarbital or mephobarbital. Okay. So long acting drugs are phenobarbital, pheno, and number 2 is mepho, pheno or mepho. It is also called, in that phenyl group will be there. Now I will show you that phenyl group will be there in the structure, and in the case of methyl group will be there. So these are called phenobarbital or mephobarbital. Okay. Next, number 2, that is intermediate acting. Intermediate acting. What are the example of intermediate acting drugs? The example of intermediate acting drugs are emobarbital and alobarbital. Emobarbital and alobarbital. So barbital is common, but in that emobarbital and alobarbital. So emobarbital you can also call it as amylobarbital. Amylo group will be there. So you can also tell it as a amylobarbital. Okay, that is number 1 long acting, number 2 intermediate acting. Next, number 3, it is short acting. So what is the example of short acting drug? Short acting drug example. What is the example of short acting drug? That is pentobarbital and secobarbital. So you have to write there pento and secobarbital. Barbital is common because all these drugs are barbituric acid derivative, so barbital is common. But along with the barbital, you have to see what is the main functional group. Okay. So long acting is phenobarbital and mephobarbital. Intermediate acting is pentobarbital and emobarbital and alobarbital. Short acting is pentobarbital and secobarbital. And ultra short acting will be, ultra short acting drug is thiopental. So ultra short, in that you will see what is that? Thiopental. Thiopental. What is that? Thiopental. I think it is also important to inform you that this thiopental is also used as general anesthetic. General anesthetic. Okay, that is also used as general anesthetic. Now we will see the SAR, that is structural activity relationship of barbiturate. So before going to the SAR of the barbiturate or barbituric acid derivative, I think it is important to know the structure of the barbituric acid derivative. So what is the structure? Structure is 6 membered, having 2 nitrogen and also 1 3 5 ketone group will be there. Okay. Hydrogen, hydrogen and NH like this. So do you know how to start the numbering of any heterocyclic ring? So what is the priority? Priority is OSNP. OSNP. What does it mean? First you will number the oxygen, then sulfur, then nitrogen, then phosphorus. Like this. This is the priority order for numbering of any heterocyclic ring. Okay. Now we will see the numbering of this one. Okay. So in that case we will start from nitrogen 1, 2, 3, 4, 5, 6. So in that case, can you please tell me what are the position of oxygen or position of ketone group are 2, 4 and 6. 2, 4 and 6. So what will be the IUPAC name of that? Hexahydropyrimidine 2,4,6 trione. Yes or no? This is pyrimidine ring or not? So when there is 6 membered ring having 2 nitrogen, so first of all for 6 membered it is called IR. Okay. So in the case of 6 member it is called IR. So pyrimidine. Pyrimidine. Now how many hydrogen are there? Since there is no double bond, so it is hexahydro. Hexahydro. So you can tell the exact name, that is hexahydro pyrimidine, and then 2, 4, 6 trione. Hexahydropyrimidine 2,4,6 trione. Or you can also write it as 2,4,6 trioxohexahydropyrimidine. So 2, 4, 6 trioxohexahydropyrimidine. 2,4,6 trioxohexahydropyrimidine. Yes or no? Now the most important thing that you need to understand is the barbituric acid is less pharmacologically active because of the presence of the 2 protons at C5 position. So can you please tell me where is the C5 position? These are the 2 proton, 1, 2. Because of the presence of these 2 proton, that barbituric acid derivative are pharmacologically active. Okay, but in that case, if we are taking long acting barbituric acid derivative, that in that case what will happen, that 2 hydrogen will be replaced with some other group. Okay, so in the case of long acting barbiturate, what will happen? In the case of long acting barbiturate, what will happen? The structure will be as it is, like that, but here this H was earlier there was 2H, now this 2H will be replaced by 2R group. This H will be replaced by 2R group. So modification at which position? 1, 2, 3, 4, 5, 6. So what is that position? Fifth position. So modification at fifth position is very very important. So you have to remember the first point is modification. Modification on ketone group. Modification on ketone group. Number 2 is nitrogen atom at first and third position. Nitrogen atom at first and third position. Next, number 3 is modification at fifth position. Modification at fifth position. Okay. So ultimately these three modification are very very important. Okay. It's half an hour. Let's complete there.